My name is Nate Beck, and this is developing games on the Flash platform. So I guess they say the best for last. That's my Twitter account, so if you want to heckle me via Twitter, go for it. So I'm just going to give you a little background about me. I've worked for a lot of corporations, and I've worked for a lot of startups. Most recently, I worked for T-Mobile, and then I also worked for Boeing, and then I've also worked for some small startups called Snapvine and a whole bunch of other things. But ultimately, so during the day, I work with Universal Mind, and at night, I kind of fuel up, and I do a lot of game development kind of in the background. So a lot of this talk is going to be about something called Push Button Engine. And Push Button Engine is an open source Flash game engine that I'm a contributor of. I'm one of 17 contributors. And it's pretty cool, and I'm going to show you why it's cool. But ultimately, I like to call myself a corporate refuge. So recently, I've just found out, with corporations and things like that, that a lot of the time spent working, for the man. I found that doing a lot of the fun stuff, like doing games and things, is how I kept myself real interested in this kind of Flash platform. There's only so many times that you can write a bar chart and not get bored by it, So that's kind of what pushed me to Push Button Engine. And I haven't shown anyone this yet, but I'm gonna take you a little blast with the past. So I have what I call here the folder of shame. So I've been doing hobbyist Flash game development for a really, really long time, since about 2002. One of these files here, I've got Flash Risk, and I'm actually going to open it up. I'm surprised it still actually compiles. But basically, this was my... who here has been using Flash since when you did timeline stuff like this? I mean, Antonio just did. Okay, yeah. So I mean, Flash. This is what we used to do before Flash Builder and Flex and all this stuff. We used to do this kind of stuff all in the timeline. I mean, that was pretty much what we did. And there's things like, hold on, let me Alt F9 to open up, this, and so we've got stuff like that. And that's how I stored my territories in this thing. I didn't know what a class was or anything like this. This is around 2002, Flash 6, actually. Random territories, select colors and things like that. But what's really funny about this is, this is AS2 and, hold on. Okay, is anyone else pissed off of how the panels work in Flash Professional? Okay, I'm not the only one. My actions panel, I can never resize, so it's always missing half the panel below the screen. So same thing here. I can't even move it, do anything to even show you what I was going to show you. But anyways, when this compiles, you'll actually see that it's actually running. And so what happens here is it jumps into the game. So I never actually finished this project because it was a nightmare to keep maintaining and add features and things like that. So for me, it was more of a learning exercise. But I can go through, and there's 3 players, so I can place each color's units as they kind of select which ones they want. Ultimately, you go through all this stuff. And then I also, the first things I did was I did the dice logic. So all the logic of the game, though, 3 dice versus 2 dice. I was so proud of myself. I was, kind of a newbie at a lot of this stuff, but it actually gives you the results of who wins what. And then one of the funny things is if I wanted to change kind of a lot of this stuff, I can say random as my set of choose territories, and it'll actually go and randomize all the different pieces, and then you can continue to go through and place units, and there's a lot of variables at the top stuff. So I mean, basically, none of us are impervious to, we all go through some learning phase of, being, learning how to do a lot of this stuff. So that's that. And then later on, I picked up kind of there and created this one called Dominion, which was going to be a Facebook version of the game. And this one was actually a holistic approach. This is when I was starting to learn object-oriented development type stuff. And so there was a lot of, I think this is AS2, it was probably AS3. But, I've got a lot of code, and I've got my own little, set of all these events and game logic, and I was using Red 5 as the multiplayer server and all this other stuff. But a lot of kind of what I figured out is, and then I've got this tower defense game because everyone and their mom wants to write a tower defense game. And so, I mean, who here plays desktop tower defense or has played it before? Really? Oh, you guys are missing out. Wow. Okay. So, but basically, I've always been kind of a gamer, and that's really kind of where a lot of my experimental stuff has come in terms of working in the Flash platform. And so basically, kind of a little bit of background of Push Button Engine. So is anyone familiar with Torque, the Torque game engine? Just a few of you. Basically, Torque revolutionized the way that independent game studios made games. It was created by Garage Games out of Eugene, Oregon, and basically what they did is they kind of changed the way that you made games in terms of, idealistic best practices and organizing your code in ways that are maintainable. And it was $100. It was no one had done that before. Created this huge game engine with all these plugins and things like that, and sold it for $100. And so a lot of companies like PopCap and Big Fish Games, and it's a C++ engine. And so a lot of games use that kind of as their base. The US government was one of their biggest clients. They do a lot of physics simulations and things like that with Torque. It's kind of fascinating. So, but basically what happened is Garage Games was founded by Jeff Tennell and a couple of other folks down in Oregon, and they're responsible for they did The Incredible Machine. They did a whole bunch of, Jeff Tennell specifically has launched, I think, 250 games. And so, but basically, he founded Garage Games, and they basically sold to another company called Instant Action Corporation or something like that. And their plan was to make Torque available via the web. So it makes sense. Everyone's built all these games in Torque, and they want to create this new and allow developers to push their stuff to the web. And they created a new plugin called Instant Action. Well, have any of you heard of Instant Action? Not a single hand. So obviously it's not doing very well. So Push Button said, you know what? There's this Flash thing that's really doing well, and we really like Flash, and we think that that could be basically the console for the web. So they created Push Button Engine. And Push Button Engine is basically Torque moved to Flash and redeveloped in a new way, and it's actually been open sourced completely. So one of the really cool things is you don't have to pay the $100 anymore. So it's made up of industry veterans, tribes, The Incredible Machine, $100 Torque engine, kind of all that stuff. One of the main people you need to know once you start getting involved with Push Button is Ben Garney, who lives in Eugene. He's about 6'5" and he's red bearded. And if you see him at a conference or anything, you have to give him a hug. It'll freak him out. I'm just waiting for him to tell me somebody just randomly hugged me. It just hasn't happened yet. But basically, going over, it's created by game veterans. Adobe is kind of really big on it. Ted Patrick, one of my things is in every presentation I do, I have to quote Ted somewhere. But basically, nothing but impressed with PvE. It's the future of Flash gaming on the Flash platform. It's open source. Refactored Conventions, when we first released it, Ben was a C++, C# dev. He didn't really understand how a lot of us Flash developers did our development. And so the conventions that were used felt really dirty to program against, because all of a sudden, you're used to programming the way you program, and all of a sudden you got mixed case variables and method names, and you have no idea what the hell is being called. So I actually went through over a weekend. I had another picture that's me drinking an energy drink, but basically over a weekend refactored the entire engine, which is how I got involved with it. The community, I think, last time I checked, it was 1,500 people on the forums. We've got 17 contributors, so it's active. Here's kind of a list of the features. I more want to jump into code, just kind of show you some of the cool stuff, by demonstration. But I'll run over this real fast. We'll talk about components and entities, resource manager, how to manage all your resources. Is anyone familiar with the term blitting by hand? Okay, a few of you. Blitting, we'll actually show you, but it's a way to render more things on the stage at a time than you can do via other methods. They're sprite-based and Swift-based. I'll get more into that. There's a component store. That's one of the big things that Torque had. Torque had this component store where people made real-time strategy kits and MMO kits and things like that. And so Push Button is doing the same thing. Although there's only one component kit on the store right now, which is the platform starter kit for building platformer games like Mario, things like that. It's got a profiler, XML serialization, time management, and a console. Console's really cool. I'll show you that. A whole bunch of gameplay components for health. Rendering 2D we'll jump into. Input manager we'll touch on a little bit. We have wrapped other component frameworks, Box 2D, so if you want to plug physics right in. Networking server, sound manager, so we'll jump over. But ultimately, what kind of stuff can you build? So this is what I'm working on right now in my free time, which is a cards kit for building cards games, not just blackjack or playing card games, but also like collectible card games, things like that. So you could build Magic the Gathering or things like that using this whole set of components. So I'm going to put that on the components for very soon. This is something called Stroids by Phil Perrin. This actually is not really Braid, but it's the platformer starter kit using Braid's assets. Now, who here has played Braid? Man, you guys really need to start gaming. I don't know how you do this. I could not get through life without this. But Braid is a really cool game that's available on Wii, Xbox, things like that. But it's got this really interesting mechanic where as soon as you die, or at any point in the game, you can reverse what you just did. So it actually plays the game backwards, and you can go back. And so it's a puzzle game, which is really crazy because you may jump on that guy, but then you'll reverse, and he'll be back alive because you went back before the time you killed him. It trips the crap out of me when I play it because then they start throwing other mechanics at you. Same exact platformer kit, just different assets. Here's another platformer. This one's really cool because it's got a complex lighting scheme. So you can only see the lights on either side, and it's actually just 2 masks on each side, but it's actually really cool. This is one that I'm currently working on as well. It's called Grunts. I'll give you a demo of that. It's kind of a tower defense type game with a few twists. This is one of the examples that comes with push buttons called Rollerball Game. I'll show you this one. This one's called What a Dream, What a Nightmare by a couple of college students. There's a lot of people doing social games. A lot of people right now, so Farmville and all that kind of Farmville stuff that people are doing, the new hit thing is to build a SimCity type game. So this is one called Utopia. This is another one called Social City. Both excellent games. And they're all built using push buttons. So push button isn't, it's there to help you out in managing and how you're going to build your game, not so much dictate what type of game you're going to build. So let's jump over real fast to some demos, because that's usually more fun, and I need to get you guys more well-versed in a lot of the games out there, because unbelievable. All right. So Stroids, you guys are pretty familiar with this, I'm sure. It's kind of your space shoot-'em-up type game. In later versions of this, it's actually really cool because he adds some extra things. I know, I'm sorry. But basically, he adds power-ups. He also has hyperspace jump where you hit spacebar and you randomly jump. That's right. Oh, yeah. So anyways, and then you can also put a shield on and things like that. So that's Stroids. Let's jump into the platformer demo real fast. So, hold on, Oh, there's no sound in this build. Okay, but anyways, he can do a double jump, and he can collect things, and he can wall ride, kind of like the new Mario style thing where you can jump off the wall and do things like this. The really cool thing about this is that these level files, where the people are and all these things, they're all XML defined. And so there's a really cool editor that you can use. And Phil actually has a really cool example where he goes through and shows you how these levels are created. You actually just paint the tiles on how you want. It's a really cool editor that you just kind of draw the level as you want to see it as it works. And then as you load the next level, it loads the next XML, and there's all kinds of things. There's an example, too, where every time you go to a new level, it reloads all the assets to a different asset style, so you can switch between, so it goes from this to Braid to some other type of asset swapping all at runtime. It's pretty cool. Here's the Braid example. So this is an older version, but using the Braid assets. The cool thing about the Braid guys is they actually, I think these were Creative Commons, that's why we're using it, but they actually gave their assets away. So you can actually just use them and plug them in. And when I talked about blitting, all these games are using blitting for those, and we'll show you that. Let's jump into Rollerball Game real fast. So this actually comes with the engine when you get it, and full source code and everything. But ultimately what's cool about, that's right, sound and everything. But what's really cool about this is, it's kind of hard to see here, but the shadow underneath the ball, it's not just a static shadow. It actually, underneath, you'll see the ground's kind of bumpy and things like that. And I'm not actually touching it, but it's kind of rolling. There's some incline there because there's a bump map underneath there that it's actually adhering to. And so you see the shadow actually conforms to the bump map that's underneath. And it's got some cool physics. It'll go down there and grab, and if I let go, it'll roll back into it, things like that. So this is just, an example just to show how you can put a game together, how to put some simple UI on it, do some simple collision detection and things like that. So that's all included. I think my best score is 22. So if you beat me on that, you let me know. Okay, I don't really need to show mine enemy. Okay, Guardian of Dreams. This is one that was, it's actually Flex. I don't know if you saw, there was the Flex loader on this one. But you play the game and you're actually you've got this little fairy that kind of follows your cursor as you move around. So when you begin your adventure, there's this ogre in the bedroom that basically as you, turn down a little, oh, he caught me. But basically as you move around, you have to trick the ogre into spinning to try to catch you, but to catch these other guys instead. And it gets really, really hard because they have like these guys that appear over on the side over here that like shoot projectiles and stuff. So it gets really hard really quick, and when I beat the first level I was extremely excited. But so you're trying to keep them from getting this little girl sleeping with her teddy bear. So I didn't say I was good at it, I was just saying. Okay, and let's jump into grunts real fast so we can kind of clip along here. So this is one that I'm currently working on. We're getting ready, hopefully, to launch it pretty soon. But this is one of the things, I wish I had a slide. I'll allow it. I wish I had a slide. There's a slide that Ben has that is basically shows, if you look at console games and computer games in general, the stuff that people were doing back in the 80s with, hardware accelerated or hardware sprites and things like that, and then moving on to software rendering, and then fake software rendering, like with Mario 64, and you follow that trend. We're getting to that kind of era now in Flash where we can start to do software rendered stuff with, so we can do typically Super NES, N64 quality games now within Flash, and it's pretty straightforward to do that stuff without, so it's kind of interesting. We're innovating at a more rapid pace than the people before us, because a lot of people are crossing over from the game industry that have a lot of these things. So what's interesting about it is a lot of the games that are out in Flash, I mean, there's hundreds of thousands, if not millions of these games, were mostly created by people like me who came from this background of, Flash timeline and didn't really understand this game, like how to really build games. And so I think Pushbutton is one of the first engines out there that's kind of this crossover from the actual game industry into this kind of market. But basically, I'll show you what Grunts is. I'll do a new game. And so I'll go into the mission here. And basically, it's kind of a tower defense-based game. So I'm going to set a couple of units. I'll do 2 right here. I'll put some sandbags down right there and right there. And then I'm going to put some barbed wire down, which slows people down, slows the infantry down. So I'm going to go ahead and start this. I'll actually see that the plane flies through, and these guys get dropped down. And then what you're going to see, if I open up my field report here, you'll see that I'm going to get, oh, that's the next wave. Next wave, I'll get 1 infantryman and 2 bazookas. So I'm going to have these guys come in. They're going to hit this. They're going to, run in, and these guys are going to end up, taking them out. And ultimately, the point of the game is to protect your commander and to protect your missile silo so that you can launch it at the end of the level. So let me put, and then you can also, you can upgrade unit. You can sell units. Yes, I'll sell him. I can move them around based on however many moves I have, how many times I can kill them, things like that. And it gets more complex because next one you'll see this little jetpack thing. So after this one goes by, this next wave comes through, you're actually going to see this little jetpack guy that gets real sneaky and kind of flies over all my stuff, and he'll fly over the thing. But one of the cool things about Pushbutton is you can really start to profile things and figure out. I'll show you some of my debug stuff that I was working with. So if you notice, the green line is actually the pathfinder that each unit is using to try to find the quickest path to their objective. So, and it's funny because when the round starts, some enemies will go for, you'll see one's going directly for the commander, which is this guy right here who's running. Actually, he's going to run into here and try to blow up my defenses, which he was killed before. But you'll notice that people have multiple objectives as they're trying to get through, and you'll see that. And then the color of the line represents what's, and green is running, gray is dead, red is shooting, orange is reloading. There's a whole bunch of things. But ultimately, we ran into this issue where the enemies would start running towards the objective and then turn around and start running backwards, but just kind of run in place. And this is how we had to figure out how to debug it. And I'll explain why this kind of falls in. The other thing that's interesting is the white circle is what's called interpolation. As the units move towards down the path, you don't want your unit to zigzag and turn 90 degrees and do these kind of, because the paths aren't straight, they're based on tiles. So you want them to walk in a straight line. So what happens is that white circle, when it gets to an area, it tries to figure out the straightest path it can walk furthest along the path without hitting anything. And once it figures that out, it can actually walk along that path because it knows it's not going to collide with anything along that path. So, but ultimately, I'll turn that off, and I have my little, oh, he's fine. I have my little I win button, which basically beats the level. And so the jet, the sound is unsafe. So it flew off in the sound, but it hasn't taken off yet. There it goes. So anyways, that's kind of, victory, you win the level. So that's actually a really fun game to play. I'm really excited to ship that soon. So let's jump back into here real fast. And getting set up is really simple. You basically go to the push button website. You either download the source code or grab the SWIC. People have shown you how to do, plugging in SWICs. You can basically plug a SWIC into your example. For me, I just created a Flex project, a Flex library project, and added it to my properties here. So go to properties, build path, and basically added a project and just pointed right at the push button engine project. Oh, thank you. It's those lights, man. It's crazy. Anyways, so that's all hooked up. It's all set up. That's all you need to do to plug into push button. So I'm going to show you a real quick Hello World example. Can you guys read the font? Try to make it big enough. Okay, sweet. So the Hello World example is pretty straightforward. Once you've got push button either through SWIC or source, you basically make this call here, pbe.startup, and you pass in a reference to the main application, which in this case is Sprite. You can also do this with Flex. It's a little bit different, but you can use Flex for this. And then I'm just going to log game over, so it's the kind of shortest game you could ever have. But let's go ahead and see what it looks like. So I'm going to launch it here. And so there's nothing here except for the console. So one of the first things that I told you about is the console is built in. And the console is really cool because you'll notice we see Hello World Game Over at the bottom here. But if I type in help, you're actually going to see there's a whole bunch of stuff that you get just for using kind of this console. There's things like I can list the display objects, and it'll actually show me my console is on the display list, so I can actually see it's there and see that it's visible and all those things. And there's a whole bunch of other things. We'll get into that more importantly later. But version is also a really good thing. It tells you what version of the engine you're using. It tells you if you're using Flash, Flex, or Air. It also knows what sandbox you're running in. I'm running in local trusted right now. That's really good for figuring out. Sometimes if you move a Swift out to like the desktop or you move it out of your bin directory, all of a sudden it can't load any assets. And that's because it's no longer in the security trusted area. So that's kind of one of the issues that we get probably 3 or 4 times a week on the forums. Like, oh, I moved my Swift, or I sent it to my friend, and it no longer works. And so we're like, well, when you open the console, what does it show? And they're like, oh, it's local with file system or local with networking. So that's why we put that in there. But that's really all it takes to get the basic game kind of started. And so now I'm going to jump over real fast to another presentation that talks about understanding components. So components in push button are a lot different than components in Flex. And I'll just walk through it real fast, but inheritance is kind of broken, especially when with regard to games. So let's say you've got your player object that you'll have in your game. Ultimately, in Flash, what people do is they'll write player.as. In some of my code, there was a player.as right in there. And then as you move along, you realize, oh, I need to have an item in my game as well. So they both need to exist in the world. They both have to have an XY coordinate somewhere, things like that. So you generate a game object class. So then you have game object, player, and item, which inherit from it. And then what happens is you decide, okay, now I need to have objects that move through my game. So I have a mover class that can either apply physics or all those other things. And then you have your player and your enemy that use that. Well, what ends up happening is what happens later on in the game as you innovate and you figure out, oh, I need to have an item that can move as well. Well, item's not a subclass of the mover class. So you can either add moving item or you can put it underneath. But regardless of which way you do it, you're going to duplicate some functionality somewhere. And so what ends up happening is everything gets shoved up the tree into the base game object class. And so Ben Garney has a story. He worked on Marble Blast Ultra for the Xbox 360. And they ported the Tribes 2 code, or the Tribes code base over. That's what they used to build this game out. Well, the Marble in Marble Blast Ultra, because it's the Tribes 2 base, and they had, I think it was called Simple Shape Renderer, was their base game object class. It could do things like attach to a jetpack or eject shells, things that no Marble has anything to do in a Marble Blast Ultra type game. But because it was based on the Tribes code, they have this massive class that had a lot of functionality that was kind of overkill. So instead, you can use composition. And the way this works is instead of having classes that have all the information that you need in it, you basically have entities. And this is what we call them in push button. But you say, I have a player, an enemy, and an item. And then ultimately, what I want to be able to do is add pieces to them that do what I need them to do. For example, I can have a spatial that, so they exist X, Y. I can have a renderer so they can show up on the screen. And then what's really cool about doing it this way is you can switch the mover out for something else. I can have a keyboard move my player, AI move my character around for an enemy, and then my item can bounce off walls or be thrown or things like that with physics. And then you can have some functionality that actually doesn't exist on other things. You can have health on a player and no health on an item, so you can't destroy the item. And then what's really cool is all these different things inherit from component. And there's a component-based class, we'll talk about that. But ultimately, then inheritance still works in this case. So then you can have a base mover class, and then you have a mover, keyboard physics, and an AI mover, so they all kind of plug and play together. So the way PBE does this is we have a bunch of interfaces called iEntity, an iEntity component. You get an iEntity from allocate. I'll show you how this works in code in just a second. And then basically you add it, you add components to it, and then you initialize it. And that's all you need to do to create a game object. And so then, basically you have the components. The components are of type entity component. They usually subclass it. And the way you add logic to a component is you override the onAdd, the onRemove, and the onReset method. OnAdd gets called whenever you add a component to an entity. OnRemove is when you remove it from an entity. And onReset is called on all the other components on an entity when you add another component to it. So as you add more components, they can rewire themselves up if they need to. Ultimately, the biggest thing you need to know is you don't put any logic in the constructor of a component. So, and then there's naming, and I'll jump into naming in just a second. So let's jump in and show you kind of how this actually plays out in code. So basically, I'm going to call startup. And then the next thing I'm going to call is just a helper method that we have in push button. This is just basically give me the basic scene I need from push button and just don't do anything else. Just give me a basic rendering 2D scene to render something on the stage. And then I'm going to call this create hero method. So what I'm going to do is I'm going to say give me a hero of type entity, and you call pbe.allocate entity instead of new entity. And the reason you do that is if we want to reuse entities, it's much easier to just, it's called object pooling basically, and you say, I want to have an entity that someone's not using anymore, I just want to reuse that one instead of creating a brand spanking new one. So that's what you use allocate entity for. Then we create a new variable called render, call it of type simple shape render. We add it to the hero component, and then we initialize the hero. The strings are basically based on naming, and I'll show you where that plays in a little bit. But basically, if I run this now, you'll see that's our hero. Pink circle to the rescue. So, and the console still works. We got all that information. If we look at the list display object, you'll see I've got my scene view, you've got my hero, and then I actually have hero.render. So you'll see that it all shows up in the display view. And then there's something called tree view. And tree view actually shows you all the entities and components that are in your scene, or in your game. So you'll see SceneDB, that's actually the rendering 2D stuff that initialized scene used. And then there's our hero of type entity, and then our renderer of type rendering 2D simple shape renderer. So moving from there, let's jump into here. So next thing we want to do is we want to basically hook two components up to each other and allow them to communicate. So I'm going to show you this, and then there's some slides, but we can probably get by without using them. So same exact thing, except now when we create the hero, we allocated our entity. We're going to create a simple spatial component, and I'm going to set the spatial positioning on the spatial component, and then I'm going to add that component to the hero. I'm going to create the renderer, exact same thing we did before. I'll jump back to property reference in just a second. And then basically I'm just doing some things to the renderer. I'm going to set a fill color, I'm going to set a line color, a radius, and add that to this component as well. So now we've got two components on an entity, the hero entity, and they have names. Now, the naming system is used for doing things like property references. So I can say on the renderer, the render has a thing called a position property, which is basically saying, this is where I'm going to look to tell me where my position is. So by default, I'm not going to use it, but if you set this, this is where I'm actually going to render in the game scene. And so that allows the spatial to plug in and tell it, actually, I want you to render at -300, -150. And because I give it the name spatial, within the same component, you can use @ and the component name, and then the property on the component that you want to use. So what's going to happen here is when I run this, it's actually going to render a little bit off. Now, in push button by default in rendering 2D, the XY axis 0, 0 is at the center of the screen, not the top left. That's the default. You can actually change that just with a couple of lines of code. It's real simple to switch it to. Actually, you can do top left, top right, anywhere you want. But basically what that did is because that spatial component is now telling it where to go, or the renderer says, okay, I'm going to look for the spatial component to tell me where to render, that's how it knows where to kind of position itself accordingly. So that's, let me just breeze through those other slides real fast so we can, in case I didn't miss anything. Hold on. So basically, all these talks are actually online, narrated. I'll give you that URL at the end. But same thing as we talked about before. So you've got this kind of the concept of a spatial, which has the position. You've got a renderer, which has the color of the object, and you have the health, the health of the object. How is it destroyed? Things like that. So those are the three properties we're going to talk about in here. And basically, your health dictates whatever color you want the renderer to work with. And then the position is also pulled in. So you've got the position and health dictate to the renderer, and then the renderer dictates color based on kind of different things and figures out where to place it and draw it on the stage. So direct is the way that we actually used, is what we use there. So basically, it's the simplest but the least flexible, and it basically, you grab a component and do stuff directly to it. It's fine to do that for initialization, but later on, when you do things directly to a component, maybe that component doesn't have the reference that you need or things like that. It becomes really brittle. Basically, the entity supports things like lookup component by name, which you can pass in the name of the component, and it'll give you back the component. You can look up components by type. You pass a class in, and it'll give you that entity back. Here's just examples. It's basically what you're normally doing when you're working with components or working with variables within Flash. The cons, though, is you end up with this, what we call dependency hell, where you've got this thing depends on that property being there, and it doesn't really plug and play very easily. So you may build a component very specific to one instance, but it's not going to work for another instance because it depends directly on some other component that may be there. Maybe it depends directly on the health component. So within my render component, if I had a direct reference to a health component, maybe the object doesn't have a health component. I can't reuse that renderer. That's kind of this brittleness, and it's hard to scale it up as your game gets larger. So properties, and that's what I just showed you with the property reference, is a really simple idiom using a string to kind of look up properties within an entity. And so it allows you to basically plug and play components within each other. And then if you need to have some complex behavior, you can use getters and setters, public get, within that to have when I set the position property or when I set the render property, maybe I want to turn the color red when I get hit. I can say, I can call a method or a getter and setter, and you can add that complex behavior to it. Ben likes to think that they're like patch cords. You're basically wiring these things together to make this complex game object from simplified components. So using property reference, and basically you can call on the entity, you can call set property and get property directly on the entity. And we'll show you that in just a second. The other thing that's cool, so here's the syntax. So at component, so you can get the component in the field name. You can actually drill down even further, so you can say like .spatial.position.x. The other thing is it supports arrays, so if you put a number in there, that's like the index of this on this list of targets. And then the other thing you can do is you can actually go all the way global and call something on the entity level. So I can say, in this case, I could say hero.render.color, and I can set it that way. And then the other way, which is really cool, I won't show you in this demo, but you can also dispatch events on entities. So your health event may just say, I'm going to dispatch an event called I just got hit. So when I get hit, I dispatch, so this entity health dispatches that it got hit. So health's like, someone just deducted health from me. I'm going to dispatch I got hit on the entity. And then the other two components that get wired in say, hey, I'm listening for a hit event. to do something. Maybe I want to flash red. Maybe I want to splurt some particles or something like that. So those two components sit independent of each other, but because the health component dispatches hit to the entity, it actually can listen for those events. So one of the things that was really weird for me is the individual components themselves don't dispatch events. All the events are dispatched from the entity level, and the way you do that is by calling owner. Owner is a property on every single component that is the entity that owns me. Owner.eventDispatcher.add event or dispatch event. So that's how you can throw an event from within a component that goes on that kind of event bus. And so that's kind of the real quick overview of that. So if we go back to here, you'll see the position property is now using that naming syntax, the component name spatial.position. And spatial itself has a position, I don't have access to it, has something called spatial or position on it, which is just a point, which I set right here. And so what ends up happening is that's how we get that real interesting moving it around. So as I make changes to spatial, you'll see that using components, I can actually start, if I don't want a simple spatial component, I could do a box 2D spatial component and just hot swap it out and plug that other component in. Now all of a sudden I've got physics that are dictating the XY coordinate of where this thing should render. So using that kind of basic example, we're going to create, I have this little simple mover class. And all the simple mover does is it has a position reference, and it extends something called ticked component. And ticked component basically is something we have in push button that you override on tick. And it's basically saying every time something happens in the engine, or every time there's an interval to grab, so basically the frame rate, things like that, I want to do something. And in this case, what it's going to say is I'm going to grab the position by saying owner.getProperty. And if there isn't a component at that property reference, I just want to quit out on that tick. So maybe it hasn't been added yet or any of those things, but it's going to try to look and see if it's there. And if it doesn't, it returns. If it does, it basically checks the position based on, we're going to say, I want it to go back and forth. So if it's going to hit some bound, and then it's going to drop down 20 pixels and then go the other direction. And then all it does is it sets the position direction based on, every time it ticks. And then I call owner.setProperty on that property reference to reset it back where it was. So in this case, what we did here is we said, so the renderer is based on where the spatial is, and then the mover is also referencing that same position. And so on tick, and then I add all three components to this. So when I run this, you'll see on tick, it's actually going through and moving this thing, and then when it hits the bounds, it goes back and forth. So the logic is actually separated from all this other stuff. And if I go to the tree view, you actually see I've got hero, spatial, renderer. You can actually see the tree hierarchy of your entities and your components all within there. So moving on from that, you can start to add complexity to this. And most game development is kind of an iterative process. So from there I said, you know what, I want this thing to move based on a mouse mover. So instead of viewing just this weird, back and forth, there's some logic in here that basically says, I want to move towards the mouse. So now what happens, oops, that's hello world, that's not what I want. There we go. So running here, you'll see that as I move the mouse around, same spatial, same renderer, but now I've got a completely different behavior based on which mover component I plugged into there. And again, as I said, the mover components can also be subclassed from the same class, and you get this real unique kind of behavior. And then same sort of thing, we can now plug into keyboard events. Let me jump over to the keyboard mover. Keyboard mover basically says if the key is right down, or WASD, depending on your preferences, I can basically come in here. Oh, I did it again. I can come in here now, and if I use the arrow keys, I can actually move around based on, same thing. So the mover can be keyboard or any of those things. And I mean, that same kind of paradigm of developing with components entities is across the whole engine. So it's not just based on input of manipulating things. So moving on from there, I'm going to jump into kind of sprite sheets. And sprite sheets are used in a lot of games. But basically, this is an animation of this kind of ninja guy that's running. It's hard to see here. You can see it a little bit over there. But this little ninja guy is just kind of running. And he's actually what's called a sprite sheet. And let me show you what he looks like. So that's him chopping, him hitting, him kicking, running, stopped, talking, throwing, walking. Where's his run? Hold on. R, ninja run. So here's him running in 8 directions. And what the reason you do this, especially for grunts, you saw, the thing about grunts is, as you get to later levels, we may spawn 50 units to come at the same time. And so in a lot of games, they do like, a tower defense game, as they spawn a whole bunch of creeps or a whole bunch of enemies. What ends up happening is, as you get more and more units in there, it slows down tremendously, because the game has to calculate a lot of that vector information to determine what the pixels are to render. So one of the fastest things you can do in Flash is to say, okay, here's some bitmap data. Here's a whole bunch of pixels. Cut these pixels from here and paste them. It's one of the fastest things you can do. So every time you render, all it's doing is, based on the direction that this person is running, I'm going to say index of 0, which is that top left picture. I want to copy those pixels, throw them right on the stage, and that's it. That's all it cares about. I don't need to do any calculations. I don't need to figure out, what color is this circle, any of that other stuff, like the simple renderer. It draws it, and so it has to calculate all that information. And that allows you to get more and more, in the example of grunts, you can get a whole bunch of grunts on the stage rather than the grunts being, something that was drawn via vector or things like that. So that's kind of the standard that a lot of these things are going. And you'll see he's got a whole bunch of other animations. He's got, front kick and a side kick and all this other really cool stuff. So the sprite sheet, that's really it right here. And the way this works is, instead of, and it gets a little bit more complex, but basically I embed the sprite sheet in instead of loading it at runtime. You can do it either way. But basically I create an entity called the sprite entity, or I have an entity that houses all of my sprite sheet components. And the reason I do that is, if I want to have a ton of ninjas on the screen, I don't want to load a sprite sheet with that bitmap data for every single one of those ninjas. I just want one, it's like in Flash with symbols and things like that. You want to just reuse. So it creates a sprite sheet entity, same sort of format though. It uses what's called a fixed size divider to slice that sheet up into its little cells and set the points. It knows how many frames are per each direction. But here's what Create Hero looks like now. You basically have a sprite sheet renderer instead of a simple shape renderer. You basically tell the sprite sheet to go grab from the sprite sheet entity, grab the Ninja Run sprite sheet component, and it plugs it into this renderer. And then you have a direction reference. And the direction reference is plugged into this Ninja Animator. And this Ninja Animator is really kind of straightforward. It has a number based on, what angle do I have this thing at? So 0 through 360. So 90 would be, 0 starts at south, so 90 would be east. And then on tick, what it wants to do is, if there's a renderer plugged into this, I want it to grab the sprite index and just basically move the sprite index, loop it through. So that's just the basic animator. So then, oops. So in sprite sheet, once we do that, that's all it is. So all it's doing is it's going to animate the ninja and then basically add it to that same thing, plug it in, and that's how we get the illusion of animation, which is actually just the ninja running through over and over again. And then moving on from there, another iteration of this is, now I want to be able to move the ninja around with the keyboard. So this is where it becomes really cool, is all I need to do is exact same code as before, except now I'm going to add a mover component and just wire it in using this kind of property reference mentality. So spatial position and animator heading, direction reference, and position based on the mover. Everything's wired in, so I'll show you what the Ninja, I don't know why it's there, but basically Ninja Mover. This is basically exactly the same as that other keyboard that we used, except now it also sets a heading reference based on which way I'm going. So if I'm going up or if I'm going down, it tells it which way to rotate, which version to play. Oops. So if I use the keyboard now, you'll see I've got my ninja running this way, but if I go there, you'll see his back. Left, you see him running that way, and kind of gives that whole illusion of you've got this little ninja that's running around. Now, ultimately, when I let go of the key, I should have him idle and stop. I don't want to show kind of starting in multiple sprite sheets and things like that. But you can see how you can give that whole illusion of the game. It starts to look like a game really, really quickly. And then from then on, we go to kind of even more complex, or maybe I want to use the mouse to do it instead, using the exact same thing, pull the sprite sheet, and then basically instead of using that, this code's exactly the same, except it's now using the Ninja Mouse Mover. And the Ninja Mouse Mover basically says, on tick, set my position, get my heading from the references that they're at, And then based on the distance between the x, y, just some, funky math with math A10 and things like that. And then it resets them again. And as soon as you do that, now you've got this, damn it, I did it again. So now I've got that guy. He's going to look towards the mouse. And then the interesting thing about this one is it actually will do, because it's using that math to figure out which way it wants to go, it actually is going to, he can use all 8 directions of him. So before, we were only using the 4 up, down, left, and right. Now he'll actually look more towards the mouse based on where he's going. He'll actually use all 8 directions. So, and you can see very quickly, you can kind of figure all this stuff, not figure it out, but get really far very quickly. And there's a lot of resources. I think Lee was posting a whole bunch of sprite sheets online that he found of like Mega Man and yeah, Google for sprite sheets. You can find them all over the place. These ones are Creative Commons. I'm actually going to put them out on my blog. But one of the #1 questions I get is, how did you create that ninja? How did you get all those things? And I have this little tool that I created in Flash called ZaFuse. And hopefully it opens. There we go. Basically, ZaFuse allows you, it's not pretty, but it works. But I can go in and I can say, here's all these, once you get your Ninja assets, you can go in and be like, okay, here's some BMP files. Here's the guy being hit, all the different things. And this is normally how you'll get sprite sheets, well, not sheets, but sprite assets from like a person. And for grunts, using grunts as an example, each grunt was developed in 3D Studio Max and then rendered with 8 cameras around him, and then just every frame ends up being a JPEG or a BMP or anything like that. And so you end up getting these things, and this tool actually just takes them and allows me to kind of fuse them together into a sheet and save them. Or I can actually animate him. You can see what he looks like when he actually is animated. Let's see if I can turn the background black so you can see him a little bit better. So he'll play through, and you can play all that. And then you can actually just export that. And then what's really cool is the way this works is it actually plugs right into Pushbutton. So you can actually take that sprite sheet and plug it right in. And so that's how each of those sprite sheets that I had work. OK, so any of these components we covered, PBE properties, how they communicate. All right, so now we're to questions. Anybody?
Can it be used with 3D engines like PaperVision?
Absolutely. So ultimately, all you would need to do to plug into PaperVision, so just the same way we did Box 2D. Box 2D it's its own library that a lot of people use. All we did is wrote just a couple of wrappers that go to that entity component model. And so you can say, OK, I want to plug this entity in. So then it uses the physics of Box 2D that ultimately just map to those XY coordinates on the spatial component. And that way you can use a Box 2D spatial component, and then it applies to all the rules of the whole Box 2D scene that you set up. What are things that can be collided, what are walkable, what are not, things like that.
How do you invoke the console?
How did I what?
Invoke the console?
The console is just the tilde key, so like most games you're used to. And you can actually change the hotkey to whatever you want. So it's pretty straightforward. It's just one line of code to switch to another key code.
Is that something you can remove in the file?
Yeah, so when you compile with Pushbutton, there's actually a flag you set before you call startup that says this is a shipping build, and you set that to true, and it rips out the logger, it rips everything out. Yeah. Go ahead.
Did you put in any functionality for testing purposes to do cheat codes?
No, not yet. But some of the fun things for testing and getting straightforward. So you saw like in grunts, I could just hit the comma key, and it actually would just beat the level for me. So I mean that's kind of the same thing. One of the cool things about let me jump back real fast to the just the spatial hero. Jump into him real fast. So one of the cool things that the console does, though, so I've got this spatial that's kind of sitting there, right? And if I hit help, you'll see in the console it has a whole bunch of other methods. One of the really cool ones is get, set, and call. Get, I can basically say get, and then based on, if I hit tree, I'll see I've got hero render. So I can say get pound hero, so that using that syntax that we were talking about, dot render dot, not position, or spatial, I can say spatial dot position. And you'll see it actually kicks back the actual thing. But now I've got set there as well, so I can say, oh, and the console also supports a lot of bash type commands. So like up and down will go through the history. It has tab complete as well. So, but I can set the position. Actually, I'm not going to set that one. I'm going to set the render.fill color. I'm going to set it to 0xFF0000. If I do that, you'll see the ball turns red instead. So you can actually start manipulating things at runtime. You also have in the list, you've got call, which means I can call a property or a method. So I can invoke a method, pass in properties to it, and get the result all within the console. You can also do dispatch, which is if I wanted to dispatch, if they were listening for a hit event, I could actually dispatch the hit event right from the console and see how it, how it performs. So, any other questions? Go ahead.
You guys experimented with augmented reality games?
I haven't done it. I know a lot of people that have though, and it's really cool. I know somebody that has a private set of augmented reality kind of components with push button, so they decided to use push button and wrote their own complex set of components that do it. I mean, the thing about push button that's interesting is you have to fight that kind of carnal instinct to develop the way you normally develop, which is like, okay, when I think about object-oriented, I need to have a player, so I'm gonna have a player class and all this other stuff. And it's getting around that kind of thing. That was one of the hardest things for me when I was starting ramping up on it, was understanding the difference between, okay, what is a game object actually? And it's actually just a collection of logic that is wired together that's reusable. And that's kind of the whole point of it. So.
How similar is it to Torque?
It's that Torque uses the exact same model. So if that's one of the reasons they did this is so that they can try to get a lot of the game developers that were using Torque or things to come over to something more familiar. So, any other questions?
Do you know of anyone that's making any games, mobile games, for Android?
Me? I'm working on one right now. I haven't really gotten far into it yet though. I know a lot of people want to see grunts on mobile. One of the things about grunts though is it's actually using Flex, so it's kind of heavy. So I have high hopes for it, but I don't think it's going to run well directly on mobile devices. So, anybody else? And I'm going out to Red Door as well afterwards. So if you have questions, be sure to ping me or pick my brain or anything you want. So last slide, information from Pushbutton, pushbuttonengine.com. We do have an IRC channel that a lot of us hang out in pretty much all day. And so it's on Freenode, it's PB Engine, and I think on average we get about 20 to 25 people that just kind of sit in there. It's kind of a lot of fun, a lot of interesting conversations. And then the quick talks, there's actually 5 or 6 quick talks that are actually out there. I only showed you the slides for 2 of them, but that tiny URL will take you to those. My blog's blog.napeck.net, and you can get a hold of me on Twitter and my email. Thanks.